Okay, now yesterday we have done the OSI reference model. Now there is another model, reference model, that is DOD model. It is also called TCP/IP model. OSI model is just a reference model. It is not like everyone uses like that. So basically we use this TCP/IP model. This internet protocol suite, the internet protocol suite, which is called TCP/IP, it is not a protocol, it is protocol suite which contains lots of protocols. This is a suite of protocols used for communication over the internet. The TCP/IP model was created after the OSI's 7-layer model for two major reasons. First, the foundation of internet was built using the TCP/IP suite. Basically, the foundation of internet is created on the basis of TCP/IP protocol suite, and through the spread of the world wide web and internet. So TCP/IP has been preferred. Second, a project researched by the Department of Defense consists of creating the TCP/IP protocols. The TCP/IP model, similar to the OSI model, is compromised with layers. Now OSI has 7 layers and TCP/IP model has 4 layers. Now these 4 layers are same as those 7 layers. Those layers are network access layer, internet layers, and transport layer and application layer. Now, as I said, they are similar to OSI layer, but they are only 4 layers. So upper layers, like 3 layers: application, presentation, and session. I have told you yesterday also that these 3 layers are for the network part. Suppose if you talk about network, these 3 layers do less job because they are related to application. Handling those 3 layers, the job of application. So handling of these 3 layers is the job of only application. That means it is handled by application. So what TCP/IP did, it combined these 3 layers to make a single layer which they call application layer. So they have combined those 3 layers because these 3 layers do the same job and it is handled by the application. Application just like operating system or any other application, system applications or any other application. Now those applications actually built on these different network protocols. So any network application we have, so those applications works on those different networking protocols. Networking protocols like HTTP, FTP, DHCP, Telnet. So when we see that which protocol works on this layer, in that image you can see, if you say like which protocols works on this layer, so it is almost all the protocols. almost all the protocols like telnet, ssh, ftp, sftp, scp, smtp, pop3, imap, http, https, bgp, dns, snmp, syslog, ntp, wins, R. So there are lots of protocols. So all those protocols works on this particular layer. So those applications designed on those protocols, so those protocols works on this layer, and that layer is application layer. So in the TCP IP model, DOD model, they did what? They combined those three layers to create only one layer, and that is called application layer. Then they created transport layer as a separate layer, because this is the layer who combines the upper layers and lower layers. So they leave these layers as it is, and it is also called, in TCP IP model, it is also called transport layer. And on this layer, if we say which protocols works, so we know that there is TCP and UDP protocol works on this transport layer, which decides the transmission of data, whether it is going quickly using UDP or going surely, that means reliably, by using TCP. But it goes slow. As we have seen yesterday also, what is the difference between TCP and UDP? Then we have a separate layer for network. Now the network layer is also separately available here in TCP IP model. It is doing the same job, only that layer name, the name of the layer is what? Internet. And it do the same job to add the information about the IP addresses. Which protocol works here? It is the main IP, which has the information about all the, it is like it is a logical address of any device in your system. Then other protocols are also there which works here in this layer, which is ARP, reverse ARP, that is RARP, IGMP, ICMP. So these protocols are also works on this layer. The job for the ARP protocol is to resolve the MAC address to IP address, and reverse ARP is the job of it is the job of reverse ARP is reverse then our ARP, that is to find out the IP address by using the MAC address. And then ICMP is a protocol which control the network messages. That is, when you ping someone, when you try to connect some other machine, you do try to ping those machines. So when you try ping command, so if it is connected, then it will get you the reply messages. If it is not connected, then it will get you connection timeout, unreachable. Those all messages are handled by this ICMP protocol. And also IGMP protocol. Now this IGMP protocol is in place of ICMP. In IPv4, IPv6, now it is use IGMP protocol in place of ICMP. So these are the protocols which works here in this layer. Then we have data link protocol, data link layer and physical layer in OSI model. Now this data link and physical layer, actually they do same job, not same job, but physical layer does not do anything, any more thing. Like we have seen yesterday also, that data physical layer don't do anything, it just transmit the data. So basically all the job done on this part is by data link layer. So what they did here in OSI TCP model, they combine these two layers to create only single layer, that is called network access layer. So that is why we have 4 layers only, apart from 7 layers of OSI model, because they combine those first upper 3 layers to create one layer and lower 2 layers to combine to create only one layer. Now which protocol works on this network access layer? These are the physical protocols which works here, and they are responsible to transfer data from one place to one machine to other machine by using the physical communication. And for that it is using the Ethernet for local network, and these other protocols are for WAN network. These are for WAN network like token ring. Token ring is also for low LAN network. Then frame relay, ATM, SONet, SCH, ECH, CC, CDMA, GSM. So these are the technologies, these are the protocol which uses on WAN network. For LAN network, we can use Ethernet. Ethernet is the LAN protocol which used in the star topology, and token ring is for the ring topology we have seen. So these are the protocols which uses on physical layer. And these are the job of these layers. For example, application layer, this layer is comparable to the application, presentation and session layer of the OSI model, and all combined into one, and it provides a way for applications to have access to network services. And this layer also contains the high level protocols. The main issue with this layer is the ability to use both TCP and UDP protocol. For example, TFTP uses UDP because usually on the LAN this physical link are short enough to ensure quick and reliable packet delivery without many errors. SMTP instead uses TCP because of the error checking capabilities. Since we consider our email important information, we would like to ensure a safely delivery. So just like SMTP for mailing, we use TCP secure reliable protocol, and UDP we use for bulk transfer. Basically it is used to send the bulk data and send it quickly without any problem and without any authentication also. And that protocol is like a TFTP, trivial file transfer protocol. Do what? It transfer multiple files at the time quickly, and for that it uses UDP. Then we have transport layer. Now transport layer is same as what? The transport layer of OSI model. This layer acts as the delivery service used by the application layer, and again the true protocol used are TCP and UDP, and the choice is made based on the application transmission reliability requirement. Now remember which protocol use TCP and which protocol use UDP. We can't decide it and we can't change it. This is the thing which is already decided by the creator of the protocol. That means who designed the protocol, they have already decided that our protocol is going to use TCP or UDP, because some protocol means they are carrying important data, so they use TCP, and some protocol using not important data but speed is important for that protocol, so it uses UDP, and we cannot change it. It is fixed. This thing we can't change. It is already fixed. It is already decided. So the transport layer also handles all error detection and recovery, and it uses checksum acknowledgement and timeout to control transmission and end-to-end verification. So unlike the OSI model, TCP/IP treats reliability as an end-to-end problem. Reliability, that means data must be reached to the destination. And then internet layer, this layer is the routing and delivery of the data is responsibility of this layer, and is the key component of this architecture, and it allows communication across network of the same and different types of carries out translation to deal with this similar data addressing scheme, and it injects packet into any network and delivery theme to the destination independently to one another. Now because the path through the network is not predetermined, the packet may be received out of order. So the upper layer are responsible for the reordering of the data, and that is what transport layer, and this layer can be compared to the network layer of a OSI model, and IP and ARP are the major protocol used at this layer. IP is to assign the unique addresses for each host, that means a machine or node, and ARP is also unique to get the MAC address of the machine by using the IP address. Now ARP works. I will show you this in, okay, I'm going to show you this. Now, network access layer, this is a combination of the data link and physical layers of the OSI model. Now, which consists of the actual hardware. This includes wire, network interface card, etc. And other related details within this layer are connectors, signal strength and wavelength along with various others. It will use the required LAN operating algorithm such as carrier sense multiple access collusion detect, that is CSMS/CD, or IBM's token passing, etc. And is responsible for placing the data within a frame, and the frame format is dependent on the system being used. For example, Ethernet, LAN, frame relay, etc. So they will decide like how the frame of the data will go, like in one frame how much packet we can send and how what will be the size of the packet. So this frame is the package that holds the data, and in the same way as an envelope holds a letter. So the frame holds the hardware address of the host and checking algorithm for data integrity. Now hardware address means physical address, and that is what we can also say MAC address. This layer has actually not been specified in details because it depends on which technology is being used, such as Ethernet. So it is actually not defined because in a LAN network we use Ethernet, in a WAN network we can use frame relay or something else, and in a WAN network we don't have MAC addresses. In a LAN network all the communication done on the basis of MAC addresses, physical addresses, but on the WAN network there is no MAC addresses. So that is why this layer actually is not been specified in detail because it depends on which technology being used, such as Ethernet or any WAN technology. So this is the DOD model. Like we are having OSI model. So OSI model is a reference model. So basically we use this DOD TCP/IP model.